Well, over the past 13, 14 weeks, we've journeyed far, and we've made our way to the last section of intermediate algebra, which is writing the equation for a circle. Kind of an interesting way to wrap up the course in that I think this might be the first thing we've done all semester that isn't a function. A circle is not a function, and yet obviously circles are all over the place. How do we write an equation for a circle? We can write an equation for a line, for a parabola, for cubic functions, and so forth, but how do we write the equation for a circle? Let's take a look at a couple of different cases to write equations for circles. So here's a little graph that we can work with, a little picture. Here's the center of my circle. So suppose I have a circle that's centered at the origin. This is the radius of my circle. Well, if I move over to the right and I move up and down, I'm going to create a right triangle. So if I start at the origin, this is how far right that I go. And that's how far up I go. So I can start by writing the Pythagorean theorem, right? C squared equals A squared plus B squared. Well, in this case, the X and the Y are my two legs, and the radius is my hypotenuse. So maybe I flip it around, I put X squared plus Y squared equals R squared. So this is the equation for a circle centered at the origin, with a radius of r. Okay, what if the center is not at the origin? What if the center is somewhere else? So let's get ourselves another circle. And this time, I won't specify that it has to be centered at the origin. I'm going to just center it at some point. Let's call that point HK. Why? Because that's what mathematicians use, so let's be consistent. All right, so there's HK. Here's my radius. I can draw the radius anywhere as long as it goes from the center to a point on the outside of the circle. What's the point on the outside of the circle? Let's call that point XY. The distance between the center of the circle and the point on the circle is the radius. So back in the old days, we had a distance formula that looked like this. The distance was the difference between the x's squared plus the difference between the y squared. Add them together, take the square root. Well, now, what if I think of that distance as x minus h squared, right? So I'll take the first coordinate here, the first coordinate here, subtract them, plus y minus k squared. But you notice that that distance is really the radius. So maybe I can replace my distance with the radius. All right, so this is really just the distance formula looked at a little bit different way. Now let's square both sides. All right. So square this side, square that side, and I end up with a formula that says r squared equals x minus h squared plus y minus k squared. And really, we again, just like I did with the other one, we usually flip this around and we say that the equation for a circle not centered at the origin, x minus h squared plus y minus k squared equals r squared. So this is a circle with the center of h and k and a radius of r. Sometimes you think of it as x minus the x coordinate, y minus the y coordinate, and then the radius on the other side. Which means if I gave you the equation in this form, you would take the opposite of the first, opposite of the second, square root of the third, get your answer. Let's see how this actually works. All right, so we already ran through those. Here's 4 equations. Center and radius of each one, and then make a sketch. Now, as best we can, make a sketch. For the first one, if you don't see any set of parentheses here, then it's centered at the origin, because that x squared and y squared is the equivalent of writing x minus 0 squared and y minus 0 squared. So right away, the center is 0, 0. What's the radius? The radius is the square root of 16, right? Because it's x squared plus y squared equals r squared. Take the square root, and I get 4. Now, how do you graph these things? Well, you start at the origin, and then you just move left, right, up, down. So I start at the origin 0, 0. I go 4 units to the right. I go 4 units to the left. I go 4 units up, and I go 4 units down, and then I try the best I can to graph something that looks like a circle. Yeah. All right. Look at the second one. The second one is not centered at the origin. So remember, the formula is x minus h squared plus y minus k squared equals r squared. So if it's x minus h squared, then the first coordinate of the center is just 3. This says y minus k, but this says y plus 5. Well, isn't that the same thing as y minus a negative 5? And then my radius is the square root of 81, which is 9. So this is hard to graph without a piece of graph paper. 3, negative 5 is down here, so you would go 9 up, you would go 9 down, 9 left, and 9 right, and you would draw yourself a circle. For the third one, if you catch on now, the pattern is take the opposite of this, the opposite of that, square root. So the center here is negative 2, positive 1. The radius is the square root of 75, which I can rewrite as 5 square root of 3. When you go to graph this, you're going to have to get a decimal approximation for 5 square root of 3, because that doesn't mean a whole lot to me as I'm trying to graph it on a piece of graph paper. But if I can get a decimal approximation, type in 5 times the square root of 3, it's 8.66. So you do the best you can to start at negative 2, 1, a little more than 8.5 up and down, left and right, and you're good. All right, number 4 looks a little funny. It says x plus 2, y minus 3 squared less than or equal to 16. Well, we can find a center. Center is going to be negative 2, positive 3. Radius is 4. So when I graph negative 2, positive 3, where the radius of 4, it comes up here, down here, to the right, and to the left. So I graph, rough graph. But that less than or equal to means something. What it means is that I want all the values where the radius is less than or equal to 4. So I'm going to shade on the inside here. So instead of just graphing the circle, I'm also including all of the points inside the circle. If it were strictly equal to 16, that would just be the boundary all the way along the outside. But this one says less than or equal to 16, so include the points on the inside. If it was strictly less than 16, I would make a dash around my circle rather than a solid circle. And if it was greater than or equal to 16, then you've got a really funky looking circle in that you include the outside but not the inside. Right? And I'd also mention that these circles are not functions. Remember when we talked about functions, we talked about making a vertical line test, and if the graph passes the vertical line test, it's a function. Well, here, if I start drawing vertical lines through my circles, they don't pass, right? They intersect at more than one point. So circles are not functions. You can't graph them as f of x equals something because they're not functions. All right, this says find an equation for the given circle. So now it's just a matter of taking our formula and applying the information we have. So the center of 0, 0 is easy. X squared plus y squared equals r squared. R is 6. R squared is 36. Done. All right, the second one. X minus a negative 4 squared, so x plus 4 squared, plus y minus 5 squared equals r squared. Right, so x minus the x coordinate, y minus the y coordinate. For the third one, it says the center is 0, 5 halves. So I'm not going to write x minus 0 squared. I'll just write x squared plus y minus 5 halves squared equals 4 squared, which is 16. All right, let's have a little fun here. This says find the center and radius and then graph. I'm going to pull this up on another board because we need a little space to work these guys out. All right, so the first one that we were working on, it says find the center and radius and then graph. Is x squared minus 6x plus y squared plus 10y equals negative 9. Now, I've suspiciously left some blank spaces in there. In order to figure out what the center and radius of these functions are, these graphs are, we're going to have to complete the square twice. So look at this first one, the x squared minus 6x part. I'd like to complete the square with my x's. So half of negative 6 is negative 3. Square it, and I get 9. So add a 9 to this side, add a 9 to this side. Over here with the y's, I got a y squared plus 10y. So half of 10 is 5. Square it, I get 25. So add a 25 here, add a 25 there. Once we do that, then this is factorable. This becomes x minus 3 squared, right? X squared minus 6x plus 9. Do the same thing with the y's. You're going to get y minus 5 squared. And then on the other side, negative 9 plus 9 just happen to go to 0. I get 25. So what's the center? The center is 3, negative 5, with a radius of 5. So I go to 3, negative 5. I count up, down, left, right, and draw my circle. All right, let's try the other two that were on the page. The second one was x squared plus y squared plus 8x minus 6y plus 9 equals 0. And boy, that looks like a mess. My first step is going to be to rearrange this a little bit so that I can complete the square. So I've got an x squared plus an 8x, and leave a little space here. Then I'm going to put a y squared minus 6y, leave a little space. And that 9, I'm going to throw over on the other side. So x squared plus 8x, y squared minus 6y. Subtract the 9 from both sides. This is starting to look a little better. All right, complete the square twice. Half of 8 is 4. 4 squared is 16. So I add a 16 here. And whatever I add to one side, I better add to the other side. Otherwise, it's not going to make sense. Half of negative 6 is negative 3. When I take negative 3 and square it, I get 9. So I add 9 here, add a 9 there. All right, we know how this is going to work out. This is going to become an x plus 4 squared. Over here, minus sign before the 6 tells me it's going to be a y minus half of 6 squared. And on the other side, I get 16. Now that it's in this form, I can find my center. My center is negative 4, positive 3. Radius is 4. All right, are you ready for the last example of intermediate algebra? Look at it down the bottom. X squared minus 4x, y squared plus 4y equals negative 3. X squared minus 4x, I'm going to leave a space, plus y squared plus 4y equals negative 3. So complete the square again, right? Half of negative 4 is negative 2. Square negative 2, I get 4. Half of 4 is 2. Squared, and I get 4. So, factor x minus 2 squared. Here I get y plus 2 squared. Over here, 4 minus 3 is 1, plus 4 is 5. So I get a center of 2, negative 2, and a radius of the square root of 5. Okay, so when you go to graph this, square root of 4 is 2, so the square root of 5 must be a little bit more than 2. I graph as best I can. And that's the end of this video. Actually, this is the end of this course. So thank you for sticking through all these videos and for coming along for the ride.